All right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations and writing some code for Murock's Android Programming, second edition by Joel Murock for the AWD1112 or 1112 Java programming class. We're up to Chapter 6 of 18, and Chapter 6, which starts on page 164, 165, let's make that, is on how to handle events. In Chapter 3, we learned one technique for handling events that occur on edit text and button widgets. Now this chapter expands on that knowledge to show you several techniques for handling events. In addition, it shows how to work with events for checkboxes, radio buttons, radio groups, spinners, seek bars, and basically the stuff that was described in the previous chapter. All right, so let's get started. You'll notice that we have 5 applied objectives and 2 knowledge objectives. Our applied objectives handle events by using the current class as the listener, handle events using an anonymous class or anonymous inner class as the listener, handle events that occur on checkboxes, radio buttons, radio groups, spinners, and seek bars, handle key events, and handle touch events. Our knowledge objectives distinguish between high-level and low-level events, and name the 4 types of classes that can be used to listen for events, and distinguish between each technique. All right, remember that a listener is an object that literally listens for events. So you can look at any kind of an event-driven programming language, like Java, as being where the program is sitting there listening, waiting for something to happen so it can react to it. How does it react to what happens? It reacts if you add some Java code to tell it where to react and how to react. So when the event occurs on a widget, the appropriate method of the listener is automatically executed. What you see here are some of the common listeners that have been divided into 2 groups. All right. This summary, as mentioned, is far from complete. So there's 2 basic kinds of events that you work with, and those are high-level events and low-level events. High-level events only occur on specific types of widgets. All right, for example, we looked at the editor action event in reference to our tip calculator. That type of an event only occurs on widgets like an edit text widget, but it doesn't occur, for example, on a button widget. An interface that defines a listener for a high-level event like this is typically nested in the class for its corresponding widgets. In other words, all right, sorry about that. So an interface that defines a listener, again, for a high-level event is typically nested in its corresponding widget. In other words, as an example, the onEditor listener interface is nested within the TextView class. So this listener won't work, or I'm sorry, will work with TextView widgets and other widgets that inherit the TextView class, like an edit text widget. Most listener interfaces define a single method for the event handler, such as the onEditor action listener defines a single method named onEditor action, but some define multiple methods. All right. Now, the opposite of high-level events are, of course, low-level events. Low-level events occur on any and all types of widgets. These types of listeners are nested within the view class. So these listeners can be wired to virtually any type of widget. For example, The on-click listener can be wired to any widget because you can click any type of widget. Besides clicking on a widget and quickly releasing it, you sometimes click rather and hold down for a longer period of time. And if you do that, that's known as a long click. So as an example, you can use the on long click listener for that type of an event. All right. Now, for some apps, especially for example like games, you need even more control over what happens if the user touches the screen. There you can use something like the on-touch listener, and you can see examples. So this slide had some examples of high-level events, this of lows. So again, a listener listens for events that can occur on a widget. When the event occurs on the particular widget, the appropriate method associated with that listener is executed. And you've got high-level events which occur only on specific types of widgets, and low-level events which can occur on any and all types of widgets. So the author talks on the next several pages, 168, 169, 170, 171. So these next 4 pages, the author discusses the different ways, all right, 4 different techniques for handling events. Now, most of the time you can use any of the 4. So really when the author gets done, what he recommends is he says use the one that results in the less code, in the least amount of code, and the one that's easiest for you. I would especially say the last thing. I would try all of them and see which one seems to at least inherently or intuitively make the most sense to you, and that would be the one I'd use. Don't feel that you're tethered where you have to use all of them to show you know all of them. No, not at all. So the technique we used in chapter 3 for handling an event is going to be reviewed right now. Afterwards, we'll look at 3 other techniques. Regardless of the technique you use, this step, as shown on the screen right now, is used for virtually, is used for virtually any and all types of event handling. So step 1 is importing the class for the listener. All right, so for example, this would be like for a button, and it's an on-click listener. All right, so this example shows how to handle the click event for 2 buttons using the current class as the listener. So you see we put a switch statement in here. So again, this says when you click the button with a plus sign on it, this is the button, I'm sorry, with a minus sign, that's the one with a plus sign. So the code uses the current class, which is the tip calculator activity class, to implement the on-click method defined by the on-click listener interface. It then wires the listener to the 2 buttons. To do that, all right, it uses the keyword this to identify the current class as the listener. All right, and that's what you see down here. Now, a second way of doing this, and this is shown on the bottom of 168. So the first way was shown on the top part of 169, then on the bottom of 169, the bottom half, and explained on the bottom of 168. They say the second example shows how to handle the click event for 2 buttons by creating a separate class. All right, so here we're coding a separate class. Notice class button listener, as opposed to implementing the on-click listener and putting it right into our first class, our main class. Here we're creating a separate class. The class is stored in the same file as the class for the activity. All right. Yet another way of doing this is to use what's called an anonymous class. An anonymous class means the class was not named. So notice we did not give it a name here. So since we don't specify a name for the class that implements the listener, it's known as an anonymous class. All right, but you'll notice that the on-click routine is the same here and here and here. They're all got an override, public void on-click, view V, and a switch. Override, public void on-click, view V, and a switch. Public void on-click with a view and a V and a switch. All right. Now in here, when we set the listeners, we use this, and on the next two, whoops, try it. Yeah, there we go. All right. Here we have to set the listeners. Here we have to create, since it's a new class, we have to create an instance of the listener, and then we use that class name inside of here. We also use the class name inside of here, but we've created it up here. All right. Finally, a fourth way of doing this, we can create the object for the listener without the parentheses for the method that wires the widget to the listener, and that's called, whereas the other one was called an anonymous class, this is an anonymous inner class. So it's a class that's nested within a class. This is useful if you want to use a different event handler for each widget. All right. Now, the author mentions here on the bottom of page 170, it says when to use each technique. And he says here, in most cases, you can use any of the four techniques for your app. So which technique should you use? In most cases, it's largely a matter of personal preference. However, if you need to wire the exact same event handler for multiple widgets, you reduce code duplication by using one of the first three techniques. The author recommends using the technique that results in the most readable and maintainable code. Throughout the book, the author uses the first technique because he thinks it's the easiest to understand when you get started with Android. Now that certainly makes sense, but all four techniques are typically used, especially by more experienced, all right, by more experienced Java/Android programmers. All right, so let's look at how we're going to handle events other than those button click events that we have been looking at so far in here. In Chapter 3, we learn how to handle the editor action event. Again, that's a high-level event, but now we'll learn how to handle high-level events for checkboxes, for radio buttons, for radio groups, for spinners, and for seek bars. I am now at 12 minutes. I want to go about around 10 more minutes. So this will probably again be broken up into two different lectures. So figure 6.3, which is shown on page 173 in the book, and the code is shown along with a picture here on your screen, it shows how to handle the check changed event that occurs when either a checkbox or a radio box is checked or unchecked. So you must implement the onCheckChanged listener that's nested in the compound button class and wire it to the checkbox or the radio button. The good news is by the time you're watching these videos, we will have gone over some of this stuff and as far as how it's done in regular Java. When I say regular Java, I mean basically non-Android type of Java. So you will have seen this before. So this example that you see on your screen right here, it shows how to use both parameters of the onCheckChanged method. All right, so we're passing in is checked. We're using it in here. All right, normally when I'm in here giving these lectures, it's just me sitting in a room by myself, but first my wife called, and second, a custodian came in to empty the garbage. So hopefully I'll be able to keep going now. So again, this particular example that you see right here shows both parameters of the onCheckChanged method. The first parameter is a compound button object for the checkbox or the radio button that was clicked. The second parameter is a Boolean value that indicates whether the widget is checked or unchecked. So you use the if statement in there to determine whether it's checked and then handle it appropriately with the code. Now there's another example in here that's a little, the second code example, it's simplified. It assumes that it's only wired to a single checkbox. This code, as you can see right here, unlike the first example, does not use an if statement to execute different code depending on whether the checkbox is checked. Rather, it uses the second parameter, all right, which is that Boolean parameter, to set the value of a variable named tip%. Now this is done with checkboxes, but whatever you use with radio buttons, if you use it with radio buttons, it'll be similar. So check changed occurs when a checkbox or a radio button is either checked or unchecked. The first parameter of the onCheckChanged method is a compound button object that can be cast to a checkbox or to a radio button. And the second parameter is a Boolean value that indicates whether the checkbox or radio button is selected. Now remember that when you work with radio buttons, you typically work with radio buttons in a radio button group. So the figure 6.4 that's on page 175 shows how to handle the check changed event that occurs when a new radio button within a radio group is checked. This implements the onCheckChanged listener that's nested in the radio group class and wires it to the radio group itself. Now this example that you see on screen right here shows how to use the second parameter of the onCheckChanged method. That second parameter provides the ID of the button that was checked. So the check changed occurs when a new button within a group is checked. So when you check a different radio button option, the first parameter is the radio group object for the radio group. The second parameter is the ID of the button that was actually checked. All right, again, here's another way that it can be done without the if statement. All right. Next, spinners on 176 and 177. As mentioned here, figure 6.5 on page 177 shows how to handle the events that occur when a spinner is first displayed and when a new item is selected from the spinner. Here, we implement the onItemSelected listener nested within the adapter view class and wire it to the spinner. In this example, all right, the onItemSelected method is executed when the user selects a new item from the spinner. All right, and as you can see within the code right here, this statement adds 1 to the position of the selected item and then stores the value in a variable named split. All right, remember the first item will be positioned 0, so by adding 1 to it, it'll have the actual position. All right. Now, if you notice on the very bottom there, there's a nothing selected method. As the onNothingSelected method is defined by the interface for the listener, you must put it in there, even if there's only an open and closed set of parens, as you see right here. So again, the onItemSelected method is executed when the spinner is first displayed and also when a new item is selected from the spinner. It is not executed when the user selects an item that's already been selected. So when this comes up, it'll run. And if I go from no to two-way, it'll run. But if I'm at two-way and I click two-way again, nothing will happen. This third parameter provides the position of the selected item. And again, the onNothingSelected typically doesn't have any code, but you must add the interface. All right? It's only executed when the selection disappears, which typically, again, you won't want to have happen. Seek bars on 178 and 179. Figure 6-6 on page 179 shows how to handle the events for a seek bar. Here we want to implement the on-seek-bar change listener. That particular method is nested in the seek bar class. Then we have to wire that to the seek bar. The interface specifies three methods: on start tracking touch, which is executed when the user begins to change the progress of the seek bar; on progress changed, which is the method executed as the user changes the progress of the seek bar; and on stop tracking touch, which is the method executed when the user finishes changing the progress of the seek bar. Since all three of these methods are specified by the interface, you must implement all of them, even if it's just an open and closed set of curlies. All right, but you only need to provide code for the methods that you intend to actually use. The seek bar can also be used as a progress tracking bar that's updated by the app rather than the user. So this could show the progress. Maybe you're doing a long download or something to show how far you've gotten or whatever. All right, I think what I'm going to do is, and yeah, I'm at 21 minutes, so I'm going to stop right now, and I'm going to pick it up on page 180, where we'll start on how to handle the low-level events. We'll start with a key event, then we'll go to the touch event, and then we'll go back and look a little bit more at our calculator, tip calculator program. So I'll be back to take a look at that in just a couple minutes.